Everyone. So today in this lecture we'll be discussing about non-linear devices which are not monotonic in nature. I have given the topic's name as non-monotonic devices. Well, this extract is from Jaan Kalda from its handout of electric current and circuits. Fact number 9 from the extract says that if there are more than one stable solution, then the question of which solution is actually resolved is based on the history, because internally nonlinear elements obey the law of inertia. For instance, the density of charge carriers can change fast but not instantaneously, and it will not jump from one equilibrium state to another without a good reason, such as loss of stability or disappearance of current solution branch. Now let us illustrate the idea 24 on the basis of the tunnel diode connected via resistor to a battery of variable electromotive force E. Now one thing I would like you to say you that you should read fact 9 and the relevant discussions regarding what Chan Kalda has given about this concept in the below page, because this was in the last page, means this was in the bottom of the given page, and you must read the discussions which are given in the next page about how it works and all those, though I am going to explain it here. As we saw in the last lecture, that E minus IR is equals to V as a function of I. The intersection point will give you the corresponding solution. Now there can be a family of E minus IR. So one family, as discussed in the bottommost red line, here this has only one solution, that is marked by point A. I am marking it by point A. Now E minus IR. This is the curve. There will be an instance when you increase the E slowly, and there will be an instance that E will come. This E minus IR will be tangent to the given curve, right? So there will be an instance when E minus IR will be tangent to the given curve. Let me also use red pen because everything is done in red. So there will be an instance when you will adjust E such that it will go tangentially to the given curve. Now what it says, that current obeys inertia. Suppose there is a block of mass m and you apply a force F. After some time it will attain velocity v. Can you suddenly change the velocity v? No, you need some time, because the block M has some inertia to resist its motion to the opposite direction. That is why what happens is that first it will increase, so it will have the tendency of increasing. The current is increasing. Observe that as you increase E, then the current is also increasing. So it will have a tendency of increasing. Like in case of velocity, we said that velocity is positive, but acceleration is increasing. Sorry, distance is increasing. So in this case, the current will tend to increase. Means it will have some resistance to decrease so suddenly. Now observe that you are increasing E minus E. So E minus IR will shift upwards. So this will be the second solution. This will be the third solution. There will be another solution where it will increase here. Now after it goes tangentially. Now I'm talking about this case. It goes tangentially. The line L3. Observe that if you further go upwards, then there is a problem. There will be only one solution, not an issue. Now, since there will be no solution left, so it has to force itself towards this point. So the next stoppage will be this point. The it will be like, suppose you are decreasing the solution in increasing E, then it is forced to go to the other branch of the circuit. Hope you get it. Now as you decrease the current, sorry, the value of E, now I am going from L4 to L3, the current will decrease, then L3 to L2, then also the current will decrease. Then again there will be an instance that it will reach here. In that case, it will jump again to the first branch, that is the leftmost branch. So if you consider it like a cycle, it will be a cycle like this form. Okay, so we don't have much problem here, but let me show you another. I'll be showing you another question where you might face some problems, right? So now we'll be looking at a question relevant to this concept. The question is from Estonian Finnish 2003. The question says the circuit shown is a simple tunnel diode based amplifier in given. Find the amplification factor for small amplitude signals using the following values: R is equals to 10 ohm and E is equals to 0.25 volt. So our first target will be to derive the point of intersection of E minus IR and V as a function of I. So let me show you my working on a separate page. Now you can see that at first I have tried to find the solution that will come to be some point here. This point will be my required solution, and then I will be shifting this graph by 2 units rightwards. Okay, so I shifted this graph by 2 units rightwards. Hence, if you change delta V by 0.5, you may observe that delta I will change by some factor of about, let me check, it will be coming about 3 milliamperes, or 3 milliamperes to 2.5 milliamperes. And pardon me, this delta V will be 0.02 volt, because the division, one division corresponds to 0.01 volt. So I am shifting by two divisions will correspond 0.02 volt, and change in this amount of current will correspond a change in output volt, will change correspond a change in output voltage by 10 into this value, that will come out to be 0.03 to 0.025. Hence, per voltage increase, per voltage increase, there will be an increase in output voltage by about 15, sorry, 1.5 to 1.25 times, right? Well, I am giving this range because the line is relatively thick. So whenever you will be calculating, you may find some errors in the calculation because the line is a little thicker than the pen nib. So even in jaan kalda, well, in jaan kalda answer is given as 1.4, right? With the sign it was given like minus 1.4, I guess. So I am taking only magnitude, and answer is coming out to be 1.25 to 1.5 times. Yeah, pretty close. Seems to be correct. Now we will be seeing another problem from nbpho. Okay. Well, the next question is from nbpho previous year paper. So the question states that there is a tunnel diode whose IV characteristics is given, and we used an idealized model, that is part B, and E is the correct one. In order to measure the VI curve of the diode, it is connected in series with a variable supply. The value of the electromotive force can be changed from 0 to 1 volt. The ammeter has internal resistance in range about 2 ohms. The applied voltage is 50 millivolt. What is the diode voltage VI and the current II? So first question is pretty simple. E minus IR is equals to V as a function of I. Just find the intersection with the given graph, and you get the resulting answer. And well, the answer comes out to be I is equals to about 15.3 milliamperes. II is equals to 15.3 milliamperes, and VI is equals to 20 millivolt. So this is the answer of the first point part. Second part says that let us study the effect of self-inductance of the wires. In order to take in account of such an inductance, we need to use the circuit B, where L is equals to 500 nanovolts. The switch key is kept open until the voltage is adjusted to 250 millivolt and then closed. How long will it take the current to reach I1 is equals to 20 milliamperes. Now see, in the 0 to 21 milliamperes range, you can see that current is independent to voltage. So it will just act as a normal diode which is in forward bias, right? And you know that in forward bias it acts as a simple closed wire with zero resistance. Now just for circuit B, you can just write E minus L di by dt is equals to 0. So the resulting answer will be Li1 by E, which will come out to be 500 into 10 to the power minus 9 into I1 is 220 times 10 to the power minus 3 by 250 into 10 to the power minus 3. Since at first moment there cannot be finite current, then L di by dt will tend infinite. So current at t is equals to 0 must be 0. Well, it's also written here that neglect the resistance of the ammeter. So there is no need of involving the term R is equal to R, that is 2 ohms as mentioned in step, previous problem. Since here R is equal to 0 ohms. Now further evaluation will take you to 10 to the power minus 5 and it will come out to be 4 times 10 to the power minus 8 seconds, if I remember it properly. Yeah. So this is the answer of second part. Now third part says, with the same settings as for task 2, how long will it take for the moment when the switch was closed until the diode reaches a voltage of V2 is equals to 500 millivolt. Now I want the time for the diode to reach 500 millivolts. Observe one thing, that the current is increasing. The current is increasing, so the inductor will be have some constant voltage also. Now the current is increasing, thus it will follow a path like this, as I said. Now here there is a stoppage. It faces a stoppage. Now observe that we know that current does not have the tendency of decreasing, so it will jump to the other branch easily. It will be something like this. It will jump to the other branch, that is the other straight line. Now the diode will act as a battery of opposite polarity of the given battery, which is double that of E. Since E is given as 250 volts and we know that the second branch is at 500 millivolts, right? The given battery is at 250 millivolts and the second branch is at 500 millivolt. So diode will act as a battery of opposite polarity. Now the thing is that the amount it has gained during charging, the same amount it will lose by discharging. Now it will act as a battery of 2E and here it will act as a battery of E. So again it will discharge something like this. At this point again it will jump to the other branch. Here it will again jump to the first branch. And this cycle continues. Yeah, this is pretty interesting because it will look like an oscillation. And the oscillation curve will be something like this. Yeah. Well, this is not the origin specified. Hence, it will take a time of, now the time taken will be L I by epsilon naught, which will be 4.2 times 10 to the power minus 8 seconds. Hence, we get the resulting answer. And if anyone asks me that what will be the current through the ammeter, the current through the ammeter will be the average value of current, we know, and the average value is 21 plus 1 by 2, which will be 11 11 milliamperes, because the oscillation is too fast. If you find the oscillation time period, it will come out to be 8 times 10 to the minus 8 seconds. It's extremely small time. That is why the circuit will oscillate so fast that the current will just be the average. Hope you get it. And well, there are rest parts, you can try them. If possible, I'll take it in another video. Hope you enjoyed it. Thank you. Have a nice day.